Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were doing our pattern wise DSA sheet, and in this we were doing binary search. Pattern is binary search on answers, and we will do the next question, which is aggressive cows, and it has been mostly asked in the interviews. So let's read the problem statement. It says you are given an array with unique elements of stalls, okay, which denotes the position of stalls. It denotes the position of stalls, okay. So you are also given a integer k, which denotes the number of aggressive cows. Okay, the task is to assign the stalls to k cows such that minimum distance between the two of them is the maximum possible. So the question says we will be given a stalls array, and every integer you can see now 1, 2, 4. It denotes the position of the stalls. Okay, we have to actually tie 3 cows, k cows, 3 aggressive cows here, and when you will put a cow, suppose you put on 1, okay, 1 cow you put it at 1, now second cow you put at 4, now third cow you put at what, 8. So from 1 to 4 if you put the cow, so what is the distance, minimum distance between those 2 cows? 3. Definitely if you will put from 4 to 8, the minimum distance will be like from 4 to 8 it will be 4. So what is the minimum distance out of all? Is 3. So you have to return that, and that should be the maximum enough. It means all 3 cows needs to be fitted inside this stalls, and if it is possible you have to return that minimum distance of that cows that arranged at maximum distances. We will understand this point in detail, but let's see the constraints here. Constraint says stall size can be 10 power 6. Okay, it will help us to calculate the time complexity and to optimize our code as well. That's why we always read the constraint. Now stalls of I can go till 10 power 8. It is an integral value and it can go till 10 power 8. Anyhow, it is on safe side. And the k, the minimum, like the cows, aggressive cows will be minimum 2, and maximum stall size can go till 10 power 6, means k number of cows can go from 2 to 10 power 6. Okay, so let's come here. As you know, this is the position of the stalls has been given, and suppose we tie a cow at here at this position. Okay, we tie a cow here, and if you will, can you tie here at 2? Let's see if you can tie the cow here or not. If you will tie the cow here, yes. Now can you tie here? Yes, you can. So it's done now. Yes, the minimum distance will be 1 minus 2, which is 1, and 2 minus 4, which is again 2. So minimum is 1. Can you return this? The question, that's the meaning of maximum. The question asks, if you'll see in the question now, the question says the task is to assign the stalls to k cows such that the minimum distance between any two of them is the maximum possible. Means you should not focus on putting these cows like together. No. You have to try to split them as far as possible, and out of all you have to return the minimum, and that's called maximize the minimum. So let's see how can we do that. We know ki we cannot put like this. Okay, so what should we try with? So basically we have to maximize the minimum, and that minimum is nothing but the distance, and the question asks us the distance. Suppose with one distance you tried now putting this one here, 1 cow here and 1 cow here. Yes. Why one distance? Because the minimum distance was 1. Yes, it is possible to put, and here the 2, but the distance allowed was 1. It should be at least at a 1 distance, so hence it is possible. So you putted all the aggressive cows at this distance. Yes, with 1 it is possible, but the question asks minimize the maximum, means go for the maximum distance. So now the gap, this distance is nothing but gap. Now I would like to try with 2. Okay, I would like to try with 2. Now let's try to put 1 cow here. Okay, I have put it. Now can I put at second one? Can I put at second? No. Why? Because the distance between this 2 and 1 is 1, and I am looking for at least 2 distance. So hence I cannot put at second. Now can I put at 4? Yes, I can. Why? Because the distance is 4 minus 1. What is the distance? That is 3. Yes. And now if the distance is 3, so hence the minimum allotted distance was 2, means it should be at least at a gap of 2, and it is at a gap of 3, so hence it is possible. So the next cow we can put at 4th number. Yes. Now can I put the third cow and on at 8th distance? Yes, I can. Yes, I can. Why? Because 8 minus 4 is 4 distance, and the minimum was 2, so hence I can put at 8th one. Yes. Now I have put all the aggressive cows here, so I can say yes, with 2 distance also it was possible. So when it is possible, I am looking for the maximum one. So hence now I would like to increase this distance again to 3, and now with 3 I would also like to check. So hence if 3 I can put at 1, yes. Now at a distance of 3, so 2 I cannot put because 2 minus 1 is 1. Now 4 minus 1 is 3 and allowed gap was 3, so hence I can put here. And now again at 8th also I can put. So yes, I can say कि with 3 distance also it was possible. Yes, it was possible. Now if it is possible, what I am doing? I am increasing the distance. Now let's try to do with this 4 distance, 4 gap. I can put first cow at 1, yes. Can I put at second? No. Why? Because the gap is 2 minus 1, 1. No. Can I put at 4? No. Why? Because gap is 4 minus 1, 3 and the expected gap should be 4. So hence we cannot put this here. Can I put at 4? Yes, I can put. Yes, I can put. Why? Because the distance is 8 minus 1, which is 7. Enough to put the second aggressive cows. Yes, but the third one is where you will put the third cow. Now 9 minus 8, the distance is 1 and the outer distance was 4, and hence you will keep running and you will come out of this stalls, and hence you will see कि when you tried putting the cows at a distance of 4, you were not able to fit all 3 cows, and that's the exact question. Question asks you to fit all this cow in this, but with a minimum distance, and that minimum distance should not be 1. Minimum of maximum ones. So with 1 it was possible, 2 it was possible, 3 it was possible, and 4th it was not possible. So with what it is possible? 1 also, 2 also, and 3 also, and out of this you have to return the maximum one. So that's the question. Okay, so whatever we calculated, if you see, first so you were choosing the distance, random distance. So first so you have to decide ki from where to start, like what lower value you should start with and what higher value you should go till. Now after this you have to randomly send this distance here, and you have to try fitting all the animals inside, like all the cows in these stalls. So definitely to calculate if it is possible to fit all these k elements or k cows or not, you have to write this another function. Yes, and for randomly sending this distance you have to run a for loop from a lower value to higher value. But so let's decide what is the lower value and what will be the higher value. If you see here, low can be 1, can it be? Yes. Why? Because minimum it will be 1 for sure, because if it will be 0 now. So it means ki you are actually tying all the aggressive cows at the same location, which is not allowed. You have to tie all the cows at different locations. So hence the minimum distance will be 1. So hence I can say ki yes, my lower value will be 1. Now let's decide the higher value. What will be the higher value? Can it be 10 power 9, whatever the question has been given? Yes, but we will try to take the minimum of it. Yes, we will try to take the minimum of it. Okay, as you can see, the question mentions the minimum cows will be 2. Minimum cows will be 2, and you know now ki if you will put tie 1 cow at the first position and second cow at the last position, correct? Then whatever is the minimum gap between that will be a final answer. So in this case, what is that gap? 9 minus 1, 8. Yes. So can I say ki the maximum distance you can try hitting with is 8? Because suppose in this case instead of 3 it was 2. So definitely you would like to put 1 here and 1 here. Why? Because if you will put 1 here and 1 here, the gap will be 1. If you will put one cow here and 1 cow here, the gap will be 3. If you will put 1 cow here and 1 cow here, the gap will be 7. If you will put 1 cow here and 1 cow here, the gap will be 8, and you have to return the maximum gap. Na? So hence you will try tying the cows at 2 distance, like corner distance, and hence the higher value will be nothing but stalls of last index value minus stalls of 0th index value, and that's what my higher limit will be. But for this the stalls needs to be sorted, because if suppose 9 is here and suppose 4 is here, then 4 minus 1 you cannot say na ki that is my higher limit. No, higher limit will be maximum of stalls minus minimum of stalls. So hence we need to sort this stalls, and after that it will be easy to calculate the final answer. Now the second thing which we have to put in the function, and in that function we have to calculate ki if it is possible with that distance or not. Okay, so for this I can write a for loop. Yes, I can write. So let's write the for loop. So I will write for int I is nothing but suppose gap. Okay, gap from lower value, I want to run this gap till high, less than equal to high, and gap plus plus. Okay, now with this gap I have to check if it is possible or not. Suppose I made a function okay, function, and I will send this gap. And if with this gap it is possible means it returns true. So I can say, think again. You are running your for loop from the lower value. So at 1, 2, 3, 4, previously you remember with 3 it was possible, with 1 also, with 2 also. If you will run from this part, okay, so definitely you will say yes, it is my answer. Okay, so there are two ways. Even if it is possible, don't say this is answer. Save it in an answer variable saying this can be my answer. Again you went to 2 now. Again with 2 also it is possible, hence update this with 2, because with 1 it was possible and 2 also, so definitely 1 too I don't want, so I will update this 2. Again with 3 it is possible, yes, update this answer with 3. Now with 4 is it possible? No, it is not possible. So once it is not possible, return this answer variable. One way is this. Second way is, instead of starting from lower value and going till higher value, you can start from a higher value also. Means 1, 2, 3, 4, 5, 6, 7, 8 and so on. Suppose with 8 not possible, 7 not possible, 6 not possible, 5 not possible, 4 not possible, 3 possible. So hence 3 will be my maximum, minimum maximum answer. You are able to understand now, because if 3 is that number which hits true, so hence that is my answer. So if you are starting from higher to lower, whatever first value it returns true, that will be my answer. If you are running from lower to higher, you have to save that answer, and once the condition become false, then you have to return that saved answer. So that's the full agenda. Now the second is what you will do in this function. So in this function we have to try fitting the number of cows, and if we are able to fit the exact 3 number of cows or more than that, it is okay, but at least 3 number of cows, so we can say yes, it is possible with that distance to fit those cows in that stalls. Okay, so for that we have to erase this and we have to write our code. So I'm just writing the function. Okay, in the function, suppose I want to send definitely the stalls, definitely the k, and definitely the distance with which we want to try with, or that is called gap. Okay, yes. Now we want to fit all the cows, so definitely the very first cow we will fit at here. So we can increase our cows counter with 1, saying that one cow is already sitting at the 0th location. Okay, so if it is already sitting at the 0th location, so why not to start fitting the second cow from the second location and onwards? Yes. So hence what we will do now, we will run the for loop, second for loop, from int I is equal to 1 and I less than stalls dot length, correct? Yes, and I plus plus. Yes. So I want to start from first location, okay, and because 0th location I will not touch, considering ki first cow I have already fitted at the 0th location. Yes. So assuming the very first cow I have inserted at the 0th location and the position is 1, of course. Now the second cow I can fit at the second second index or not. How can we check that? Definitely we have to do this 2 minus 1, which is 1, like gap is 1, and if we are coming with a gap 3, suppose gap 3, like we want minimum gap 3, and this gap is 1, so hence I can say I cannot put my second cow at this location. So for that we have to keep a track of our previous cow location. Yes, so that we will save in a variable, let's say last, and in this we will say stalls of 0. So that position will be my previous position of the cow. Okay, now I would like to start with 1, so definitely I have to check this. So how to check the current? So we will say ki if my stalls of I minus last index, if this difference is greater than equal to gap, then I can say ki yes, the current ith position is a valid position, because it is maintaining the gap, like difference gap between greater than equal to gap. So I can say ki yes, this position is okay to fit my second cow. But suppose I am coming to fit the cows with a minimum gap of 3, suppose. So definitely 2 minus 1 is not feasible enough, so hence we cannot put this cow here. So hence for this if case will not run, and we will move to the second I is equal to 2. Now here if you will see ki this 4 minus 1, this gap is enough. So hence we will check stalls of I, which is 4, minus last, which is stalls of 0, 1. Is it greater than equal to gap? Gap is 3, suppose. So of course 3 is equal to 3. It is possible. So can I say I can fit my second cow here? So for that what I have to do? Simply cow plus plus, cow plus plus. Yes. And also if you are moving forward, suppose you would like to go to fit the third cow, na? Now you would like to go to fit the third cow. So basically now you will consider this 8 with 1 or 4. Think again. Like now you are looking for the distance of this 8 from this nearest one or the far one. Of course with 4th, correct? The nearest one. So hence you have to update this last variable also, na? So hence you will say last is equal to this stalls of I. Correct? Yes. And after coming out of this for loop, you can say ki if the cows which has been calculated, ki if this cows is greater than equal to k, means with this gap distance it was possible to fit equal to k cows or more than k cows. So hence this gap is valid one, and when the gap is valid, we always look for smaller or greater. Remember, when with 1 it was possible, we looked for greater one. So now we can say it is possible because number of cows is greater than equal to k. So means with this gap it was possible. So hence we can return our gap only when if you are running this in a for loop from a higher location to lower side. Okay, because you are actually trying with 10, 9, 8, 7, 6, 5, not possible, not possible, third possible. So that was the maximum answer. And hence that we can return ki yes, return our what, that current gap. But if you are looking from the lower perspective, so with 1 also it will say yes it is possible, with 2 also yes it is possible. So hence everything you cannot return now. So hence you will save that gap in your answer variable, saying save the gap, okay, and keep on moving. And when our if case, like in the answer you will save the gap, yeah. And now when our if case will not pass, suppose the number of cows is greater, and this I am saying when you are running from lower side to higher side, like your gap you are taking from a low variable to high variable, for that if case will definitely pass, and that answer you will save, that gap you will save in answer variable. And when once the else case hit, you can say you can return the what, previous saved answer. Okay, but if you are coming from a higher side to lower side, correct, so for every higher case it will fail, and the very first answer which will hit and make true, that will be our final answer. So we need not to save in the answer variable, we can simply return the gap then and there. So what will the time complexity? First we are running the for loop from 1 to higher side, and that higher side is nothing but you remember, stalls of last element minus stalls of first element. And what will the maximum element? If you see here in the constraint, it says stalls of I can be 10 power 8. So hence that for loop which we are running from a lower limit to higher limit, that will be 10 power 8. Now the another for loop which you are running here for the stalls length, that stalls length it says it can go till 10 power 6. So total 10 power 14. Definitely this will give you TLE. So hence we need to optimize it here. This for loop we cannot reduce because we have to, like, we want to tie the cows in that position. So we have to go checking all the positions if it is valid or not. Valid, tie it. If not valid, move to the next position. So this for loop you cannot reduce. Now the another for loop which you are running like from a lower side to upper side, like higher side, that is already sorted. If you will see, range is sorted, right? Number line is sorted. So why to check consecutively? Why not to apply the binary logic there? Why not to check for the mid? If it is possible, then again, if it is possible, then we will go towards the right side. And if with mid it is not possible, means we have to go for a lower gap. So we will go towards the left side. And that is a logic. Whole logic will be same. The only difference is instead of writing the for loop, running the for loop, you have to write the while loop for the binary search. And that for loop which was taking 10 power 8, now because of the binary search, it will take logarithmic of 10 power 8. So let's write the code here. First we need to sort our stalls. So arrays dot sort stalls. First we will sort it, correct? And now we want a lower variable, so we will save int low, and low is equal to what? 1, minimum 1 gap, yes. And int high is equal to what? We want, if it is sorted, so we want to save that stalls of the last index is nothing but n, so int n is equal to stalls dot length, correct? Yes. So last index we have to do n minus 1 and minus a stalls of 0. So now we can initialize our answer variable, let's say 0, minus 1, whatever, because the question says answer will be there. So now we can run the binary logic while low less than equal to high. Now we have to calculate the mid index, so we'll calculate the mid with low plus high minus low divide by 2, okay, on a safer side. And now we have to check, we will make a function, suppose can place, and we will send what? We will send stalls k and the mid value, and mid value is the minimum gap. If with this it is possible, so definitely we want to save that answer which is mid, and we want to move towards the higher side. So we will move our low at mid plus 1. Yes. Else if it is not possible, we would like to go towards lower side. So for that we have to move our higher at mid minus 1. Yes. Now after coming out of this for loop, we can simply return our answer as a final answer. Now we have to write the function which is can place. So we will write private and return type boolean. We will make can place function, and what parameters we are sending? We are sending stalls, which is a integer array stalls. Now we are sending int k variable and int mid variable and distance, which is nothing but gap here. Okay. Now with this we have to count number of cows, so which will be int count or cows. So let's initialize the cows with 1 or count with 1. Okay. So assuming very first cow we have inserted at the 0th location. So now the last variable we need, so where we have inserted our cow, so we will see stalls of 0. Okay, that was our last index. Now I want to run the for loop for int I is equal to 1, and we want to run this till I less than length of stalls length, correct? Stalls length. Yes, and I plus plus. Now we have to check if it is valid, like if that length is valid, gap is valid. So for that gap we have to check if stalls of I minus the last position, if this is greater than equal to the gap or distance, then it is possible to fit the second cow, and if it is possible we will increment the count by count plus plus, and we have to reinitialize the last position with the current stalls of I. Okay. Now if it is not possible, we will keep on running, and after coming out of this for loop we can say return true if our count is greater than equal to what? K. So we can return true, saying ki yes, with this distance gap it was possible to fit that minimum k and more than k. So hence, as you can see, it has been passed. So let's submit this code as well. And as you can see, all the test cases has been passed. So this was your Java solution, and so here is your Python solution if you are from Python background with the similar logic. And if I hope you understood the logic, if yes, then you can submit the code on your own as well. And here is your C++ solution if you are from C++ background. So with this we can go in our sheet and we can mark the 4th question as to be done, aggressive cows, which has been frequently asked in the interviews. So guys, if you are submitting along with me, do let me know in the comment section by commenting solved or understood, so that I will get to know ki I am able to make you understand each and every concept. And if you guys are benefited from this video, do like and subscribe the channel, and you can even refer this channel to your friends as well. And if you guys are new to this channel, we are actually following the Rising Brain sheet. The link you can find in the description. And also if you want to connect with me at any social medias, then all the links in the description. You can reach out to me for any type of guidance. And again saying, please don't try to copy paste the solution just like that. Please try dry running on your own. Try hitting with another lower and higher value. Why only we tried with one? Why only sorting was needed? Without sorting, why can't we do? When you can answer everything, then only you can say ki actually you are learning the code, and from the next time you don't need to see the video. You can make the logic on your own, and that's the real path of learning DSA. So I hope you will submit this question on your own, and that's it for this video. Let's meet in another video with some more interesting questions and topics. So then keep learning, take care of yourself and your family.